Assistant Professor in Electrical and Sir has a Assistant Professor Internet of Things in Electrical Engineering Department. So welcome you sir on behalf of EX Department. I I'm also honored to welcome respected ED ma'am Shivani Agrawal ma'am. I'm also honored to welcome respected Director Sir Dr. Rajiv Srivastava sir, and I'm also honored to welcome HOD ma'am Dr. Smita Shandil ma'am. I'm also honored to welcome co-HOD sir Dr. Vivek Tiwari sir. Welcome sir. Dear participant and my colleagues, a very good afternoon, one and all. I am Prachi Vidhaman as an assistant professor in ES department. I feel privileged to extend my warm welcome to all present here for inauguration of this two days national conference on advance in electrical power and energy system 2023, which is a schedule from 24 April to 25th April. So, without any further delay, uh, it is a culture of sage growth. We pray to Goddess Ma Saraswati. So, I would request Rajan sir, please play the Saraswati Vandana. Thank you, sir. This program is being organized by Electrical and Electronic Engineering Department of SIRT Bhopal and in association with Relay, IETE and IE. So, it is a great pleasure for us. Welcome you, sir. So, without any further delay, please proceed this session.
Thank you. Am I audible?
Yes, sir.
Okay. So shall I start, ma'am?
Yes, sir. Yes, sir. Sure.
Thank you. So let me share my screen. I would like to request the host to kindly enable the participant screen sharing so that I could share my screen.
Now you can share.
Okay. Thank you, sir. So I hope my screen is visible and my voice is also audible to you all.
Yes, sir. Screen is visible, but it is not full screen. It is mixed type screen.
But now I have made full screen.
Okay, okay. Maybe it may take some time.
Okay, fine.
It is not in presentation form. It is just in window form.
No, but I have made it full screen. Kindly check, sir, if it is
Maybe
visible
it
now.
take 2 to 3 minutes.
Okay, fine, fine.
Okay, sir.
Should
You
I
can
share it
start.
again?
Yeah, you can start.
Okay, so at the outset, I would like to extend my deep gratitude towards the Department of Electrical and Electronics Engineering SIRT Bhopal for inviting me for the keynote in the 2-day conference. And I would like to congratulate them as well to organize such a program for students and faculty members and the 2-day conference on advances in electrical power and energy systems. So my session would be on the topic integration issues and protection challenges in microgrid, because microgrid, it is a very trending technology nowadays. So let me start my session without any further delay. So these are the outline of my presentation. I would be discussing the integration issues involved in microgrid, some literature review, the protection challenges, and some proposed techniques uh, which have been proposed for protection, imparting protection to the microgrid, and some future research directions. So let us start with what is microgrid. So microgrid is a controllable entity. Before understanding the microgrid, I would like to make a difference between the bulk generation system and the micro generation system. So what is bulk power system generation? That is the conventional generation. The conventional generation, the power which we are getting now, is being generated at very far off place, and through the bulk generation, that is mostly using the fossil fuels or the hydroelectric power generation. So the concept of bulk power generation has gradually made a transition into the conventional power system to the power system at the load center. So what happens when we are going for the bulk power generation? Then we have a lot of transmission cost and lot of the equipment failures and protection issues, and there are various issues. High amount of capital is required to set up such a power system. But if we imagine to generate the power near to the load center like the microgrid is doing, then we can ensure the reliability, because in the case of the events, the failure events, when the grid is not available, so your microgrid, which is located just near to the load center, that can feed the critical loads, and that is one factor why we consider the microgrid system over the conventional power system. So a closed controllable entity, in order to ensure reliability of power system near to the load center, and it has some limitation that it can be connected to a low or medium voltage level. So it's a microgrid, as the name suggests, it's on the micro scale. Your grid is at the micro scale, so it can provide you the high quality and reliable energy supply to feed the critical loads when your grid is not available. So one more advantage is that we can operate our microgrid in two modes. It's bidirectional in nature. When you have the surplus power from your microgrid, you can attach it to the grid to feed to the grid, like we are doing with our solar systems. In the domestic applications also, we can see that various domestic applications where we are connecting our solar PV generation on the rooftop of our building or the commercial premises, and when we have the surplus power, we feed it to the grid through the net metering. So the same thing can be done in microgrid. We can operate the microgrid in two modes, that is bidirectional. When the grid is available, your microgrid need to get the power of grid, so you can have the grid connected mode. And when the grid is absent through some region, let us suppose,
sorry for interruption, sir, एक बार और शेयर करिए, पीपीटी स्टक है, मतलब बढ़ नहीं रही आगे.
Okay sir, okay, thank you.
Okay.
Is it now visible, sir?
Now okay, sir.
Okay. I hope you are looking at the what is microgrid slide.
Yes. What is microgrid?
Okay, thank you. So I would like to repeat, sorry for the inconvenience. So the microgrid can be connected in two modes of operation, that is grid connected and islanded. So when your grid has surplus power and your microgrid require the power of grid, so you can connect through a switch at the point of common coupling, and your microgrid is ready to accept the power from the grid, that is the grid connected mode. And when through some region, through fault, due to fault or any region, your grid is absent and is not available for feeding the power, so your microgrid, your micro resources, that is the distributed generators, they are the very low level generators, you can say, feeding low power levels. So those generators can feed the critical loads in the microgrid. So it can operate in both the modes, and it is. So so why microgrid? Why we need this microgrid? Why this technology trending nowadays? So first of all, as I told you, that the concept of bulk power generation in the conventional power system has now taken the transition from bulk power to the micro level power at the load center. So your transmission distribution cost is minimized up to some extent. Reliability is increased. Your electric and gas prices are fluctuating if you are using the conventional power generation. Power quality, reliability, these are some of the factors which can be taken into account when we are thinking of the bulk power generation. Then cyber and physical security. And one more thing is there. All these issues were prevalent in some 4 to 5 decades ago. But what has happened now, in the last 2 decades, we have seen that the power electronic technology to harness the renewable power has got advanced in the last 2 decades. So that has become one reason why we are stressing over the solar power generation, why all the governments, even the Indian governments, had set apart a target to achieve 30 gigawatt of power quite some years back, and that was achieved before the deadline. And now we have planned to have the 100 gigawatt solar generation, and in future we will put it more. So why we are relying more on this? Because it's a free power, no pollution, no carbon emission. If we are talking of the solar power, wind power, or biomass, we can say that there is no carbon emission. So without affecting your atmosphere, the global warming issues, we can use these generation. So these generation technologies, it has become possible due to the advancement in the power electronics. So power electronics has made a very significant role in utilizing the distributed energy resources. Next is the value addition. It has a set of the value addition to our existing system, the efficiency, reliability, the energy security, the economic savings, and sustainability. So obviously sustainability, out of all these points, I would like to put more stress on the sustainability. So if we talk of the bulk power generation, your coal, your petroleum, or other fossil fuels, they are not sustainable. In quite some 40 or 50 years later, we will not be having a sufficient abundance reserve, coal reserve or petroleum reserve to operate our solar based coal fired based power plant, thermal power generation, or diesel power plants, or like that. So in that case, we can say that this microgrid, which utilizes the renewable based distributed energy resources, is capable enough to reduce the carbon footprint, because they are the cleaner source of energy. Okay, and at the same time, since it is located near to the load center, so whenever we require power for our critical loads, it can feed the power. So at the same time, energy security and reliability can also be achieved with microgrid. So what are the applications? As I told you, that microgrid can be installed anywhere near to the load centers for feeding the local loads. So local loads are the distribution loads, and distribution loads can be anything like the institutional campus sites, the hospitals, universities. You can set up a microgrid to feed your power to your university, hospitals, commercial buildings, or the military bases, data centers, the municipal loads. So wherever in distribution we need it, as per the scalability, we can fix the microgrid. So microgrid can vary in size from watts to some megawatts, few megawatts, not the larger megawatts, because it can be installed at the distribution site, and the distribution voltage level and the power levels are very less. So we can go up to certain megawatts, like we can say 13, 15 or 20 megawatts up to that rating. Or if we talk of the voltage level, so in India we have the distribution voltage level of 33 kV. So we can go up to that voltage level if we are planning to install the microgrid. So now I would like to introduce the distributed generation, because the concept of distributed generation is very necessary, very much required to understand, because your power is distributed. Previously, when we are talk of the bulk power generation, then your power was concentrated, your generation was concentrated. Now it has been distributed, because you are setting a small microgrid, you are setting a small generation unit near to your load center. So wherever you have some scope of solar power or wind power or some other source, you can connect them together in a controlled manner. You can synchronize, put it in a synchronism, and you can connect it to the grid, and that is your microgrid. So the distributed generation plays a major role. And again, your power electronic converters, we cannot forget the contribution of power electronic converters when we talk of the distributed generation. So this renewable power, we have a lot of sources. In one microgrid, we can have solar, we can have wind, we can have the battery energy resources, we can have the small synchronous generator, and all are jointly working, irrespective of the fact that all have their different dynamic conditions, their different operating conditions. But in a controllable manner, with the help of control system an efficient control system, we can say, and power electronic technology, we can operate them in a regulated manner in order to feed our critical loads at the distribution side. So there are various sources of distributed generation, like we can have the wind power, the CHP, the hydropower, the photovoltaic, or the fuel cells. Fuel cells are the very emerging technology, although it is very expensive, and also it's hazardous to be used in power generation, but gradually it's gaining momentum as distributed generator, and in the near future the fuel cells may replace the batteries, because fuel cells have added advantage with respect to the storage type batteries, because fuel cells have higher current density and power density also. So we can say that fuel cells are a very emerging technology. Whenever we need a sudden demand of power at the peak load demand, so that can be met by your fuel cells. Now, energy storage converters are again playing a very much role, that is the synchronous generators, the induction generators, and the power electronic converters. So if we talk of the operational conditions, so a microgrid is a controllable entity. So a group of controllable interconnected loads and the distributed generators, that forms a microgrid. So it can operate within a clearly defined electrical boundaries. For illustration, I have just put one single line diagram of a microgrid, in which you can see that this utility grid is connected through a circuit breaker. This is the point of common coupling, and this whole system containing the micro sources and the small distribution lines, this is the microgrid. So this microgrid can be connected in synchronism with the grid, and as per the requirement, it can be connected in bidirectional mode, that is grid connected and islanded. Okay, so we can have the two structures. One is the radial grid, another is the loop grid structure. So here it's the radial grid structure, which you can see. So the DG1, DG2, DG3. So all these DGs are not necessarily be the same type of distributed generator. As I told you that the microgrid consists of the distributed generations of a variety of types. It can be renewable, it can be synchronous, it can be inverter integrated, power electronic inverter integrated, or it can be directly something else. So it can be of different nature, because all the distributed generators have their own operational dynamics, of own operational conditions, and in that way we can connect it. So in order to illustrate the islanding scenario,
Only, sir,
how we
only
call
5 minutes is left.
Okay, fine.
Hello.
Yes, I can hear you, sir. Hello.
Yeah, sir. 5 minutes is left. Just reminding.
Okay, fine. Thank you.
Okay.
So, as far as we talk of the islanding scenario, so if this switch, the circuit breaker switch, is open, okay, then we can say that there is no interconnection between the utility grid and the microgrid, and that scenario is called the islanded system. So power system consisting of 4 power sources that can be separated from the rest of the system in the islanding. So what is the effect of islanding, and why do we need to detect it? Because unintentional islanding must be detected, because there can be the hazard to the personnel working there, because of suddenly, if the microgrid was operating with the grid and suddenly it is disconnected, then this kind of scenario is not healthy for the equipment and for the personnel who are operating it. So for both the cases, it is not required. It is not expected actually. So effect of islanding is to cause unbalance in the production and the load, and the frequency mismatch also arises due to this. So for that reason, islanding should be detected on time. So there are various methods of islanding detection. One is the passive and one is the active. So under passive method, we can have the local measurements like voltage and current signals, the frequency measurements, and a rate of change of power, rate of change of frequency, like this. So with these parameters, after measuring these parameters and processing them, we can devise an aligning detection method. While in the active method, some disturbances are injected, and the response against these disturbances are monitored, and through that we propose the aligning detection method. So that can be the two methods. So what are the protection aspects? That was the main point of discussion. So unfortunately, the time is very less. So I would like to highlight the major points. So as in the despite the conventional microgrids, the operating conditions of the different distributed energy resources are different. Like some are weather dependent, like the solar generation or the wind power generation, they are very much dependent on the weather conditions. So if the weather is not favorable, let's say the sun is not there, or it's there partially, or it's a cloudy weather, then you cannot get the maximum advantage of the solar power which you have installed. Similarly, if you have installed the wind power and the wind speed is not enough to generate the wind power, then also, so these are the operational dynamics associated with the renewable distributed energy resources. And due to this is called the intermittency, the sporadic nature of the distributed energy resources, and that makes the protection task quite challenging. Another thing is, we have different distributed energy resources and the fault current contributions are different. Like your synchronous generators, all of us know that synchronous generators have the prime mover, the rotor. So we have enough inertia to deal with minor stability problems. While if we talk of the inverter interface distributed energy resources, like the solar, which is coupled with the inverter, and we have the DC-DC converter. So nowhere we have the inertia. We don't have any moving part in solar or in the inverter or whatever. So we don't have the inertia. So in that case, the level of fault current contributions are very much limited. In synchronous generators, we can go up to 5 to 6 times the rated current, while in the inverter interface distributed energy resources, it's limited to only 1 to 1.5 times. So this operational dynamics also makes the protection task very challenging, because if you will put a relay which is working on pre-specified threshold setting, so that may not work, because that the directional the operating conditions are different. So you cannot use the pre-specified threshold setting based relay, the overcurrent relays, or some fuse or some protection devices which are not dynamic. So in order to pick up this dynamic behavior, we should have some adaptive technique. Either you should have some adaptive technique, or you can use some machine learning based techniques also. So I'd like to show you for this PV integrated microgrid system. This microgrid system is based on the US distribution system, that is 34.5 kV 60 Hz system, and this is containing a 20-kilometer line, and two resources are there, that is photovoltaic distributed generator and synchronous distributed generator. So it's containing two generators only. So if we are planning to implement any machine learning based protection scheme for microgrid, then we will have to go for the feature extraction, and then that extracted feature data set can be given to any machine learning classifier